So this is a talk on data mapping at Cruise. The clickbait version of the title is Data Mapping at a billion-dollar self-driving startup. I'm Marc Paré. I'm the tech lead of privacy infrastructure at Cruise. Previous to joining Cruise, I spent 3 years doing differential privacy for the Department of Energy in a project called the Secure Energy Algorithm Testbed. What are we going to talk about today? Brief introduction to the privacy challenges of autonomous vehicles, background on past data mapping efforts at Cruise. The bulk of the talk will be on what we built to address this challenge of visibility into the flow of sensitive data. And I'll try to interweave use cases for this data mapping tool as well as interesting findings along the way. All right, so why is privacy a challenge for autonomous vehicles? Well, you have sensor-laden platforms driving around major cities constantly. Hundreds of these vehicles, they're riddled with sensors, cameras, GPS, microphones inside and outside the vehicle. Not only that, but they're connected to one of the most advanced machine learning apparatuses that humankind has ever built. So the possibility for inference, aggregation is quite high. If that weren't enough, that challenge is further magnified by the fact that all of this is being done in the context of a startup environment. That is to say, autonomous vehicles are just reaching the level of technical maturity to be able to be ridden by the general public. So finally, we're collecting customer phone numbers, email addresses, their behavioral data in the form of where they're picked up and where they're going. It means that as privacy engineers, we have to deal with constantly shifting requirements, constantly shifting architecture. We have to stay quite nimble to be able to address privacy in that sort of environment. Now, one of the first challenges we noticed in that was our lack of visibility into the flow of sensitive data throughout the infrastructure. Cruise is funded to the tune of $9 billion, has 2,500 or so engineers. You can imagine there's a lot of data. It's copied around, used in any manner of ways. There have been past data mapping efforts at Cruise to try to get a handle on it. This is a non-exhaustive list of some of those past efforts. Unfortunately, those efforts were met with, at best, middling success and sometimes outright failure. It's a really tough problem. Fortunately, when I joined, after researching these past projects, we identified 4 key areas that we thought we could improve upon that would lead us to a meaningful chance of success, right? We weren't just going to repeat past mistakes with this work. Here are the 4 lessons. Number 1, manual labeling isn't enough. There's just too much data, too much sensitive data to rely on human-based labeling of sensitive data. People just forget about where it is. Number 2, mapping is a context-specific activity. So in an analogous way that you would use a roadmap or a topographic map to plan a different type of trip, a privacy engineer wants a very different data map from a data scientist. You need to orient your data mapping activity precisely to the context in which it matters. Practically, what that means is some open source tools for data mapping are not suitable for privacy engineers. Lesson 3, data mapping seems to be the type of activity that encourages scope creep. So many different things to map. Everybody's got a different use case. Many of the projects that we studied that were failures tried to do too much all at once, only got part of the way. I see a lot of heads nodding in the audience at that one. Let's see if you nod at this one too. So hand in hand with that, quite a few projects labeled a whole bunch of things, but then didn't have a plan in mind for what to do with those labels. They didn't have a particular risk in mind that those labels would help address. They didn't have a pathway from those labels to technical control which would allow them to improve privacy. You've labeled data, so what is the pithy way to summarize that? Here's how we applied these lessons to our MVP development process of the data map. We put an emphasis on building automated detectors for sensitive data. We built a data map only for privacy engineering use cases, explicitly ignoring others. We focused on a single data store, Cruise's data warehouse stored in BigQuery, and within that, we even narrowed the focus further on 2 high-value projects, not attempting to cover everything at first, just something representative to teach us what we would need to be able to scale further. Finally, we identified a use case up front, which was to archive any sensitive data that had been abandoned by its original owners. a data scientist data set that they had copied for a one-off analysis and forgotten about, that sort of thing. All right, the meat of the talk, what we built. We'll start from the user-facing web application and sort of work our way under the hood to the data pipeline and the detectors that we built. So we'll start with the web application. The application is called Indiana, as in Indiana Jones. So where Indiana Jones searches for buried treasure, Indiana, the application, looks for sensitive data. Oh, I lost my timer. That's okay. No problem. The main screen of Indiana is a filterable table of all of the schemas of BigQuery. So each row corresponds to one column in BigQuery. You'll see project, dataset, table, column name in the field. There's a search box, so you can do real-time searches for field names via irregular expression. So there's about 36 million columns that we've ingested into a Postgres database, indexed it with a trigram index, so you get near real-time full-text search capability. This is pretty interesting, even just out of the box right there, before we've done any sort of detection for sensitive data, because it enables on-the-fly, ad hoc metadata searches. Here's an example. We were on a call with a data team that told us we store raw image data in BigQuery. We didn't expect that sort of data to be stored there. We thought it was only being stored in cloud storage. They told us the name of what that data field was called in their table, and so we were able to, on the call, type in that name and see how widespread that pattern was across the infrastructure, and yeah, quite widespread, it turns out. The regular expression support is pretty interesting because you can do things like enumerate schemas in a natural way. The dot plus syntax there says any table that's called container logs that has something called latitude in it, return it to me. It's not such a fancy thing, but that sort of like platform orientation towards building the tool builds in some flexibility, which lets us like discover future use cases. A couple of simple filters. Creation date is a pretty useful one. Gives us visibility into like ongoing changes to the data warehouse, what happened in the last 2 weeks, that sort of thing. The most interesting filter are verified labels of sensitive data. So here are the categories of data that we label with automation: email address, non-cruise email addresses, names, phone numbers, precise location of a few different forms. We'll go into a bunch of detail about the system that underlies that later. But with the filters, you can do things like say, where are all the phone numbers in the data warehouse? This is also really useful for internal data access requests. So we get teams will send a privacy review. Is it okay to give this contractor this access to data? Via Indiana, we can quickly filter to the tables that they're requesting access for, check all the different sensitive data fields. The URL changes so that we can link somebody to that output view, and we can paste that into a ticket and say, no, you can't have access to all of data infra prod because it has thousands of instances of sensitive data. Please scope down your request further. Another interesting thing that these labels allow us to do are provide comprehensive summary views of the sprawl of sensitive data across the data warehouse. This is a histogram, sort of anonymized with the project names, that shows the distribution of sensitive data across different BigQuery projects in our data warehouse, which is to say the sensitive data sprawl across the data warehouse. They're found in many different locations with quite different distributions. This chart is quite powerful for communicating to senior leadership. It makes that problem of data sprawl not an abstract one, not an abstract one, but a concrete one that's turning from something that we can measure. That turns into something we can measure. One last interesting feature of this application is this sample button that pulls a random sample of data from arbitrary data sets in the data warehouse. It's really useful for ad hoc mapping activities by privacy engineering. A team will ask us, hey, is this field sensitive? Sometimes it's hard to tell just by looking at the name. We can pull a random sample of data. More detail on the service that powers that, because doing that in a secure way was an interesting design challenge. Here's just a summary of all of these use cases on one slide, just to show the sort of variety of privacy engineering use cases we were able to meet with a relatively simple tool, right? It's just a filterable table, a search box, a few filters, but we dialed it in precisely for privacy engineers, and we're able to cover quite a bit of useful things. All right, so where did the verified labels come from in that UI we just looked at? There's a whole data pipeline of scanners, a combination of metadata and content scanners. Metadata scans, they scan the names of columns in BigQuery, use a regular expression for that. Here's an example of the configuration for these scanners. This is really fast, right? It's all implemented as a single BigQuery query. We ingest the schema via Google Cloud's Cloud Asset Inventory and then run the query against it with a regular expression filter. So these are really nice. They're easy to develop. But there are limitations, right? You can't actually look into the data. That's where content scans come into play. You pull a sample of the data, run some machine learning or regular expression or pattern matching against the data and find tags that way. We evaluated a number of different approaches for that. Ended up settling on Google Cloud's DLP Inspect API, which gives you a combination of machine learning and rule-based matchers. Scaling content scans was quite challenging from a scalability point of view. Three different ways in which it's challenging. So one, you're handling quite a bit more data than the metadata scans. So where a metadata scan to scan a column just has a little bit of data from the column name, the content scan actually pulls a bunch of data from the table. So you're handling a lot more data that you have to push through the data pipeline. The second big challenge to scaling content scanning was achieving an adequate signal-to-noise ratio. Out of the box, all of the scanners from Google Cloud's DLP API provided either way too many false positives or way too many false negatives. We were either overwhelmed with findings and they were useless, or we knew that they were missing some sensitive data in the warehouse. So quite a bit of tuning to the sensor, tuning to the matchers was necessary, as well as post-processing as well. Third challenge, and this one will go into some detail here in some more slides, is how to do this securely. So you may have data that are locked down in the data warehouse that privacy engineering doesn't have access to. How do you scan that? How do you get your scanners access to that data? Well, there's a couple different approaches you might take. The simplest one would be just give privacy engineering read access to everything. De facto, kind of what was happening before. Teams would over-provision our user accounts because they'd get us involved to try to review things and be like, oh yeah, here you go, here's access to all of our data. It's hard to sleep at night, when your account is like such a high visibility target for attackers. The most complex option, well, there's probably a number, but the one representative one here are something like in situ scanners. So you send a container with code for your scanner to a team, tell them to run it, send you back the labels. But there's quite a bit of complexity in implementing that sort of thing. You have to be able to constantly push them code updates. You have to be able to debug the scanners, on and so forth. There's quite a few security challenges to reaching a successful enough implementation bar to have improved security by doing that rather than decreased it. We tried to meet in the middle for our startup atmosphere at Cruise with a secure data sampling service. We call it trowel. So you know how like an archaeologist, when they're like digging up dinosaur bones, uses a trowel to like just take like a little bit of dirt at a time so as to not damage it. That's the same idea here. We just like sample a little bit of sensitive data via the trowel service. It's a single API call. It uses BigQuery's table sample system for implementation, and it gives us a whole litany of threat mitigations just from that simple wrapping of that operation in a service. It's much easier to monitor for abuse. We have a technical control for large-scale exfiltration, targeted searches, and then, as I mentioned before, it allows us to just remove a bunch of over-provisioning from our user accounts for our day-to-day work. Last step of this pipeline is a human-in-the-loop label verification flow. It's a CLI tool, pulls samples of the data using trowel, prompts us with the name of the field that our scanners believe to be a piece of sensitive data, and we confirm or reject it. With this data pipeline, we managed to scale it from our 2 BigQuery projects of interest to all of the hundreds of BigQuery projects at Cruise, about 14 petabytes of underlying data covered, millions of tables, tens of millions of columns, thousands of findings for sensitive data, many of which were surprising. Now onto our use case for archiving abandoned sensitive data. we studied usage logs for all of data that were tagged as sensitive by this system. We found 55% of those data tagged as sensitive were abandoned by their original owners. A huge fraction. It was quite surprising. If you expand that window to say a piece of data is abandoned if somebody hasn't touched it in 12 months, that 55% number doesn't actually change much. It only drops to 43%. So the half-life of data is quite short. We sought to address that gap in data handling via an archival scheme, a soft deletion scheme. We implemented that using Google Cloud's. Oh, are you plugging me in? Thank you. Oh, has that been up the whole time? Yeah. Who's like stressed out about the low battery? That's cool. I know these. I've given this presentation so many times. I just like know all the slides. I'm like, if they turn off, I'll. Yeah. Thank you. Appreciate that. We implemented a soft deletion scheme using Google Cloud's policy tags. It allows us to not delete the data, but lock them down, mitigate a lot of the privacy risk. That was an interesting thing to develop because you all may have had this challenge of it is often difficult to fully delete data, right? You would love to, right? But as soon as you delete something that's critical to a business workflow, you interrupt it, senior leadership is on your back, like it makes your job much harder for the rest of your time at that company. So the development of this soft deletion scheme was pivotal towards being able to scale it across the entire data warehouse. All right, so closing comments. As we said at the beginning of the talk, we focused this just on privacy engineering use cases, purposefully ignoring every other team. We found that in undertaking this data mapping activity, we spun out impact to other teams anyway, just sort of happened along the way. Here's like a snippet of some of the messages we received and a description of some of those impacts for other teams. This was interesting to find. It suggests that data mapping, if you execute it well, is something not like an isolated activity just for privacy engineering, just for compliance, but something like a foundational capability for a data organization. All right, with that, if all that sounds interesting, our team is growing. We have a lot of big privacy challenges, so please come and talk to us.